Hello everyone. Today we're going to start with logarithmic, exponential and other transcendental functions. Our focus in this session is going to be on the natural logarithmic functions from the aspect of differentiation. The topics we are going to cover: we will develop and use properties of the natural logarithmic functions, understand the definition of the number e, find derivatives of functions which involve the natural logarithmic functions. Let's recall things we did earlier when we started with the integrals of the x to the power n dx. So when we did this one, we said when we take the integral, the general power rule says x to the power n plus 1 divided by n plus 1 plus c, where n cannot be equal to minus 1. This was a very, very important scenario. The reason was that we did not know how to find the antiderivative for this function 1 over x. So what we are going to do is we're going to use the second fundamental theorem of calculus to find the antiderivative for this function f of x, which is 1 over x. This is neither algebraic nor trigonometric. It falls into a new class of functions called the logarithmic functions. Now this function is a specific function we're looking at. We are looking at the natural logarithmic function in this session. So let's define what is a natural logarithmic function. The natural logarithmic function is defined as natural log of x equals 1 to x 1 over t dt, where x is positive. And this domain of this natural logarithmic function is nothing but the set of all positive real numbers. So what happens is if this x is strictly greater than 1, this natural log of x, or basically the integral of this, is always positive. And if this x is between 0 and 1, so in the scenario when it is 0 less than x less than 1, then the integral of 1 to x 1 over t dt, which is natural log of x, is a negative number. And when x is 1, the natural log of x is 0. Okay, in other words, natural log of 1 is 0. That's what I meant. Okay, and what also I said was in this scenario when it is between this, for this one, suppose x is say 0.5, natural log of 0.5. Plug in your calculators, guys. What do you get? So when you plug in your calculators, you will see that you are getting the natural log of 0.5 to be a negative number, and you get to be a negative 0.693 and something. So, and this is very true when you do it over here too. And if you take a natural number, say natural log of 1 is 0, remember that, and it's one of the biggest properties of logarithmic functions. This is coming from your pre-calculus. And if I take natural log of say 5, according to this, natural log of 5 should be a positive number. So let's plug in your calculators and see what we get. We get the answer to be 1.60 ... Okay, so this one works with what things we have learned, and it also is in sync with our calculators too, keep in mind. Okay, now the properties of this natural logarithmic functions. I'm just going to go over them with you, and when I do examples, that's when I will use these properties to make my life simple. So the first property is that the domain of the natural logarithmic function, remember the natural logarithmic function, guys, is denoted by an ln. That's what it means. Okay, the domain of a natural log function is a natural log of x. Here, that's what it says, natural log of x. Okay, is from 0 to infinity, and the range is from minus infinity to infinity. This is a continuous function increasing in 1 to 1. And the graph of this is concave downward. So if you take this one where x has to be positive, so if you draw the graph, this is how it looks like, guys. Now, these are the most important rules we will be using throughout this chapter. Natural log of 1 is 0. Natural log of a product of two functions, natural log of a and b is natural log of a plus natural log of b. And if you have natural log of a over b, it is natural log of a minus natural log of b. You can have them as positive numbers. Spelling's wrong, guys. Or you can think of some x squares and y squares too. Natural log of a to the power n is n times natural log of a. Okay. The next one is the number e. We all know that the number e, when you plug in our calculators, gives us this. It is 2.71828 blah blah blah. Okay? But the natural log of e is 1. That's also one of the properties. Notice what is the meaning of natural log. So if you remember from your pre-calculus, natural log of e means log to the base e, and this e when here comes in, the base and the value of the log next to it that means they're the same. This becomes 1. Now, as I said, we are going to be focusing more on how to find the differentials of natural logarithmic functions. So here's it. These are the formulas. These are the two main formulas. If you have a differential of a natural log of x, now this x has coefficient 1 power 1. What you simply do is you take the expression next to the natural log and put it in the denominator. This x has to be positive. It's important that because the domain of the natural log only accepts strictly positive numbers. In other words, it cannot take 0. Anything greater than 0, yes, it's happy. Now, if you have u as a function of x, if u is a differentiable function of x, then the differential of natural log of u is 1 over u times d over dx. Kind of like a chain rule, guys. That means u prime over u, and u is a positive number. So let's go ahead. Take the differential of natural log of 5x. So if you remember this is u prime. Now this, remember guys, is u. So whatever is next to natural log, differential means take that and put it in the denominator, and then go ahead and differentiate what's in the denominator. So the answer is 5 over 5x, or which is simply 1 over x. Okay. Let's look at the next one. Differential of natural log of x cube. Okay. So I'm going to show it two ways. One, I'm going to apply the property, and the other one, I'm just simply going to apply the differential formula. So basically, we're going to apply number 2. So here, because remember, this one has a coefficient different than 1. So according to the definition, whatever is next to natural log, you put it in the denominator, and then you differentiate whatever is next to natural log. So what you're getting is 3x squared over x cubed. You can do a little cleaning up here, and you get 3 over x. Now this one is applying formula. But if you use some natural log properties, you can do it even the same, easily. So I'm going to show you that way also. So here is natural log of x cubed. Now, natural log of x cubed, guys, remember, this is a to the power n. That means anything which is raised, which is a power of the function next to natural log, you can take that outside. You write this as 3 natural log of x. So if I take the differential of this, so d dx of natural log of x cubed is nothing but d dx of 3 times natural log of x. Now 3 is a constant, it comes out, and it's a differential of natural log of x. So the answer is natural log of x, coefficient 1, power 1, it just simply goes in the denominator. It's 3 over x. That's exactly what you got by applying directly the formula. Okay? So let's look at the next problem. Here we're going to look at the differential of natural log of x cubed minus 5x. Now remember, I cannot apply any properties because the natural log properties, guys, are only going to apply on functions if they're multiplied to each other here, or they are in a rational form or if they are in a power form. Otherwise, you cannot apply any of these properties. Notice, what do we have here? We have over here is a natural log of sum of two functions. So we will just have to apply it the normal formula. Okay, so what you normally do is you take the differential. So this is basically what we need to do. So that's why I have written out u prime over u. So this is your u. So you, whatever is next to natural log, you put it in the denominator. And then you take the differential of this denominator, which is x cubed minus 5x. So final answer is 3x squared minus 5 over x cubed minus 5x. Okay. Now let's look at another kind of problems. So we're going to like to differentiate these different functions. So the first one, y equals natural log of x to the power 4. Now notice, this is the whole expression to the power 4. So once again, we cannot apply any of the rules of our not logarithmic functions. So what are we going to do? So when we look at this one, think of this problem as you're going to look at the chain rule. It's a function raised to power something. So when you want to take the differential y prime, you're going to first apply the differential of the outside function, which is 4 times natural log of x, and then to the power, that's 3, and then you take the differential of the inside function, which is natural log of x. So your answer is 4 natural log of x, the whole expression cube, times 1 over x. You can write it in a nicer looking form, 4 natural log of x cubed over x. Okay, let's look at the next one. As I said, when I'm going to do these problems, guys, I'm going to try to use my log properties if I can and make my life more simpler. So, when you look at this one, so you say, oh, it's natural log of an expression which is raised to power something. So that reminds me, there's natural log of, say, a to the power n. I can use natural n times natural log of a. So I'm going to apply this and make my life much more simpler than applying the differential formula. We will do it, but later on, okay? So first we're going to make our life simpler by, applying this log properties as 2 natural log of x minus 6. Now I can't apply any of the natural log properties, remember, because there's a difference of two functions here. Now we will apply the differential. So y prime is, now remember, it's differential of 2 natural log of x minus 6. Now 2 is a constant, we can take the 2 out, and that's a differential of natural log of x minus 6. So what's this? It's 2. Remember, now we'll apply the differential property. X minus 6 goes in the denominator, and you multiply by the differential of x minus 6, which is basically a 1. So your final answer is 2 over x minus 6. Remember, differential of x is 1 and 6 is negative 6 is 0. Okay. Now let's look at the next one. Here, y equals natural log of e to the power 2 root x. Remember, this e is the number 2.718, blah, blah, blah. The one we just looked at here. Do you remember this one? 2.718, that's what we have. This is the number e over there. Okay. Now, before I apply the differential, I'm going to apply the quotient rule. The quotient rule is this, guys. Natural log of a over b, which is natural log of a minus natural log of b. So we're going to do this one here. We're going to have natural log of e minus natural log of 2 square root of x. Okay? Now, natural log of e, remember, is 1. That's this one. Natural log of e is 1. So our life is simple. Okay, so you already got this one as 1. minus, now this is the product of two functions. So I'm going to do this as minus outside. This is natural log of 2, which is going to be some number, plus natural log of square root of x. Notice I'm not doing my differentials at this point. I'm trying to make my life as simple as possible first. Okay. Now natural log of 2 is going to be a number. So it's going to be some number. So you just let it be like that. It's going to be some constant. Okay. Minus natural log of 2 here. Okay. Natural log of square root of x is what? It's natural log of x to the power half. So we are going to apply the power rule. This is the power rule, guys. Okay. This one is called the power rule. Okay, so what do you get? We have 1 minus, you can take natural log of 2 plus half natural log of x. Remember, I have not yet distributed my negative. Now we can distribute the negative. So we have 1 minus natural log of 2 minus half natural log of x. Okay, so we have nicely written down, it's the most simplest forms we can do. So now we're going to do the differential. Okay, so what we have y equals 1 minus natural log of 2 minus half natural log of x. So if I take the differential, so y prime, it's basically the differential of all the terms inside. Notice, 1 is a constant, natural log of 2 is a constant, okay? So what are we going to get? This is going to be 0 minus 0, half minus half comes out, and natural log x, differential, because it's a constant multiplied to a function. So final answer is negative half times 1 over x. You see what complicated this function looks like, but what's the differential? Y prime is negative 1 over 2x. And it made our lives more simpler when we applied the rules of logarithms. We could have done the normal, applied the whole differential, but remember, it was going to be a lot of work and more complications there. The reason is this is going to be a chain rule. So you take the differential of natural log, then you take differential of this, which is going to be quotient rules and all those things. So remember, whenever you have natural log questions, you have to find differentials. The key part, make sure if you're able to apply the properties, do that. Okay. Let's now apply the things we have learned. So what I'm now doing is I'm applying all the things we have learned in chapter 2, the differentials. Now here is a differential of two functions as a product of x cubed with natural log of x. So before I can start the differential, I have to say, I have to first apply the product rule before I can do the differentials. Okay, so before I can actually apply. So y prime, when I do it, remember the product rule of differentials. It's x cubed prime natural log of x plus x cubed differential of natural log of x. Now, x cubed differential is what? 3x squared times natural log of x plus x cubed. Differential of natural log of x is 1 over x. Clean it up. So 3x squared natural log of x plus, now this x and one of the x's will cancel out on the top, plus x squared. If you want to be more nicer, you can take the x squared out. 3 natural log of x plus 1. Okay, the next one. Again, it's a product of two functions, an x with a natural log of x to the power 4. Now remember, we have done this problem in a previous slide. Here's it. So you already have done it, but we will now do it as a part of the product rule. So when I do my differentials, the very first step is going to be applying the product rule. So y prime is equal to x prime natural log of x the whole to the 4 plus x times natural log of x to the 4 the whole differential. So x prime, simple, we get natural log of x the whole to the power 4. And this one is plus x, natural log of x. Now here, it's a chain rule. You will take the 4 out, natural log of x to the power 3 times differential of natural log of x. So what do we get? Natural log of x to the power 4 plus x times 4 natural log of x cubed times differential of natural log of x, remember, 1 over x. So the x's cancel out. What are we left with? Natural log of x to the power 4 plus 4 times natural log of x to the power cube. It's fine till here. If you want to do a little bit more algebra, it's okay with me. Let's do it just for a practice. Remember, natural log of x is common, cube. We have natural log of x plus 4. Okay. Now, remember, I could not apply any of the log properties here because natural log of x only had there was no multiplications and nothing of the powers in the products. Okay, here guys, we are definitely going to have a lot of work first. Okay, so before I differentiate, I am going to do a lot of log properties here. The first one is going to be the quotient rule. Quotient rule means natural log of a over b. That's called natural log of a minus natural log of b. This is the quotient rule. Okay, so this is going to be natural log of x times x minus 4 to the power 5 minus natural log of x squared plus 3. Now remember, we can't do anything in the last natural log expression because it's the sum. But look at the first one. It's a product. Definitely we can apply it here. We say natural log of x plus, that's called the product rule when I apply here, x minus 4 to the power 5 minus natural log of x squared plus 3. Now, nothing can be done on the first expression, but this middle expression, we can apply the power rule. Remember when I said the word power rule, that's log of a to the power n, n log of a. That's called the power rule. Okay, so which is natural log of x plus 5 times natural log of x minus 4 minus natural log of x squared plus 3. Now notice we have basically cleaned it up to as much as we can. Now we apply the differentials. Now differentiate. So y prime is what? Differential of natural log of x, 1 over x. Plus differential of 5 times this, 5 is a constant. The differential of this means 1 over x minus 4. And then you multiply by the differential of x minus 4. Minus natural log of x squared plus 3. X squared plus 3 is in the denominator, and then you take the differential of x squared plus 3. Final answer, 1 over x plus 5. Remember, differential of x minus 4 is what? A 1. So it's simply 5 over x minus 4. Then minus, differential of x squared plus 3 is what? 2x over x squared plus 3. Okay. Now, the next expression. Guys, this is a lot of work, okay? So here's the square root. I can write this as, making my life simple, natural log of x plus 1, x minus 1 to the power half. Now, first we're going to apply the power rule, then the quotient rule, then the quotient power and the product rule. So the first thing is the power rule. This is the power rule, guys, we apply, which is half times natural log of x plus 1 over x minus 1. Okay, now then we apply the quotient rule, which is half natural log of x plus 1. Now remember, This half is multiplied to both of them, minus natural log of x minus 1. Notice, we can't do anything after this because natural logs of a sum of two functions or a subtraction of two, we can't apply any log properties here. After this, we just have to do the differentials. So now we differentiate. So y prime is what? Half outside. Differential of, so it's basically this, x plus 1 minus natural log x minus 1, the whole differential. Constant is not affected, half. Differential of x plus 1 is what? X plus 1 and x plus 1 differential. So, now make sure you keep the square brackets, minus 1 over x minus 1 differential. So what's the final answer, guys? The final answer, half. Differential of x plus 1 is simple 1 over x plus 1 minus differential of x minus 1 is 1 over x minus 1. Voila, we are done. Okay, we have done a lot of these scenarios, and my recommendation to you guys is make sure you practice these log properties most of the time. Okay, let's go back, and now if we are given natural log with absolute value functions, how do we solve? Pretty simple, guys. So if u is a differentiable function of u, x, such that u is not equal to 0, then the differential of natural log of absolute value of u is the same as we're normally doing for the other values, which is u prime over u, and x is positive. Give me a second, x is positive, or is it u? I think y. Oh, there wasn't this one. Sorry. Okay. So let's look at the differential of this natural log of cosine x. The differential is, it doesn't matter if you have absolute value, it simply means that the natural log properties can function. So f prime of x is what? You take whatever is next to cosine, you put it in the denominator, and then you take the differential of the cosine function, which is negative sine x over cosine x. And if you remember, this is negative tangent x. Okay. Let's look at this one. Natural log of secant x plus tangent x. So if I take the differential of this function, it's going to be secant x plus tangent x, and then the differential of secant x plus tangent x in the numerator. If you remember, differential of secant x is what? It's secant x, tangent x, and tangent x is plus secant square x over secant x, tangent x. Now if you do a little bit more algebra, secant x is common on the top. We can take that out, secant x. We have tangent x plus secant x. The denominator is secant x plus tangent x. Notice this whole expression cancels out. Final answer is simply secant x. So we have done some trick, we have done absolute value functions, we have done a lot of practice of the log properties, and then applied differentials. So now guys, I would like you to work on these set of problems. Very important, practice and practice. Thank you.